Alright, so now let's go ahead and draw this. Okay, so when I draw this, so you should imagine that we want to replace right, this guy, this aperture with a lens, and we want to see the effects. The first thing, right, that we are going to do is, right, draw this figure. Okay, let us say that, okay, I'm going to, let me try to draw it properly. Let's say that I have a lens. You have to be, I think you have to be good at drawing things. No, this is still not good. Okay, maybe I'll draw a smaller one. But if it becomes too small, right, then not sure how it will. Alright, this is not bad. Okay, something like that. And here is where the pinhole was, and now that will be the center of the aperture of the lens. Okay, and you know that a lens has an aperture through which, and that aperture is something that allows you to control how much light should come in, just as your eyes have an aperture, right? Now, imagine that I have a point. Okay, now let me draw it with some other color. Right, I have a point here, which is in the say 3D world. I'm right, for a specific reason. Right, I'm not taking. Okay, now let me decrease the, for a specific reason, right, I'm not taking this point on the optical axis. Okay, right, this is your optical axis, this is your image plane. Okay, this is your image plane, this is your lens. Okay, and I'm not taking a point deliberately here, I'm taking it, I'm taking it here. Okay, I could have also taken a point on the optical axis, but that would simplify my equations. Okay, instead of that, I'll take it away from the optical axis, some point, right, that is sitting. Now let me just mark, if you now what will happen, right, is the following. So if you really examine, okay, now assume that my focal length of this lens, okay, is f. This is f. Okay, let me draw here. Okay, that's my focal length. Then what will happen? So we know that there are a lot of rays that are going to come out of this guy, right? And one ray, which is called the central ray, or the principal ray, is the one. Wait. Okay, is the guy that's going to go there, right, and hit the plane somewhere. Then, in order to know where things are going to get focused, right, let's kind of draw this parallel ray, which we know will pass through F and hit somewhere. Okay, so I think, so the point is, right, this ray I drew only to sort of indicate where where these rays will meet. Right? So these rays will meet here, and therefore I'll kind of remove this parallel ray because I don't actually need it. Okay, let it be there, it's not coming off. This is the problem. If you remove one, something else goes off. Okay, because that ray I just took to indicate where things will come into focus. Then what will happen? You will have another ray, right, that is going all the way, hitting the boundary of the lens, and that should also come through the same point, right? because that's the whole job of a lens. Correct. And then you have another guy that's coming from here, and that will also pass through this. Correct. Now here is your image plane. Let's just extend it. Okay. Now some point, right, so it forms. Okay. Now the point is this, right? So this is called a point light source. Okay. So it's as though, right, I'm segregating the whole scene. Now I just want to analyze one point at a time, right? I don't want to look at the whole scene and all. Just want to see that if there was a way that I could just place one point light source there in the world, what will happen? So if you see, right, now let me just indicate certain things here. Okay, now the first thing which you actually notice is that had the image plane been put here, right, then of course what would have happened is that this point, right, which is this point would have actually appeared in focus, because then a point would have kind of mapped to a point, right? So had this image plane be there. Now what we have, so since we do not know, right, we just started with some image plane sort of a distance from the lens. So in this case what is happening is, so this point is mapping into some kind of we don't know what the shape is, right? But this is called a circle of confusion. Circle of the confusion. So what that means is that a point is spreading now, right? It's no longer a point. It is mapping some kind of a confusion circle. Whether it is a circle or not, we will see. Okay, and we also know that there is something called the Lenz law, right? According to which, in this case, this is f, right? And let me call this as, what is this? U. Okay, I'm calling this as U, and this I'm going to call as U naught. Okay, let me write a few things here. From here to here is D. So the first thing is, this Lenz law is such that 1 by f is equal to 1 by d plus 1 by u. Okay, what this actually means is that a point at D would come into focus at U if the image plane was at U and not at U naught, of course, right? Or see, effectively you can have another equation that says 1 by f is equal to 1 by omega d plus 1 by u naught. Okay, this is the other way to interpret it. What this means is that because the image plane is at u naught and because the focal length is f, there is some distance called WD, and this WD means a working distance. Okay, working distance. It's called the working distance because if you place any object at omega d from the center of the lens, then that will come in focus, right? Because it will mean that instead of converging here, they will all converge here on the sensor plane. Correct. So it actually means that ideally your point should have been at omega d in order to have been able to see it in focus. But since you have not kept it at omega d, you have kept it at some other d. So what is happening is it's coming out as blurred. Okay. So this Lenz law, you can write it with respect to f u naught d, f u d, or you can write it in terms of f u naught and some other omega d. Okay. So it means that you should have brought it somewhere, to the front or to the back, and then it would have come in focus. So you can already see that, right? It depends upon how these lens parameters the interplay of these lens parameters with respect to where the scene point is, right? Now let us just add in a few more things. Okay, I'm going to draw. The nice thing about this tablets is that you can draw these colors and all. Okay, so right, this is a line kind of parallel to the optical axis, and we are going to call this as epsilon. Very good. And we are going to call this as delta. Now, okay, maybe right, if I write this, you will know that I am referring to this as delta, and I am going to call from here to here. See, right, this is the central ray. Now, the central ray is something unique, by the way. Okay, it goes undeviated. See, everything else gets kind of refracted, right? And then they all converge. The central ray that's going through is actually undeviated and goes straight and hits. So let's call the point where the central ray hits this distance. Let's call this as RB1, just to denote some radius. And let's call, so this is with respect to the outermost ray. Okay, this RB1 with respect to the outermost ray that's hitting the lens and then converging and then coming and appearing somewhere in the plane. And similarly, down below you have RB2. Right? We do not know whether RB1 is equal to RB2. Okay. Maybe if I had kept it in the optical axis, it would have been more, then you can maybe immediately guess what might happen, but not when it is here. Alright, and then there is something else also that we should know, which is this one. This guy is R0. This is the aperture radius. Okay, radius of the aperture. They have written D, I have written delta. Okay, all of this is fine. Okay, now using some simple similarity of triangles, right? Let's go do the first one. Let's look at let's kind of look at this angle. Let's look at this angle. Okay. Okay, now this is epsilon, that's delta. Okay, so what do you have? Delta. Right. What do you have? So we have delta. Delta divided by u naught minus u should be equal to, now this angle should be equal to what is the other angle? right? So, this angle, right, should be equal to epsilon by u, correct? Or in other words, delta is equal to u naught minus u by u into epsilon. Okay. Now, the other angle, right, that we can look at is, what is the other one? RB1 minus delta. Okay, let's kind of look at this angle. Okay. So, what is that? The total is RB1, from here to here is delta. So, it's RB1 minus delta, right? RB1 minus delta should be equal to, what is the other angle? So, this guy is going here, right? RB1 minus, oh wait a minute, RB1 minus delta by something I didn't write, no, u naught minus u should be equal to now r naught minus epsilon, right? Because you are looking at here to here. Is that correct? Right? R naught minus, because this whole thing is, this aperture is r naught radius, so r naught minus epsilon by u, correct? Or in other words, RB1 will be equal to u naught minus u by u into r naught minus epsilon plus delta. This is equal to u naught minus u by u into r naught plus u naught minus u by u into epsilon plus delta. But then if you look at delta, right, delta is exactly this one, right? This is delta, no? From here, u naught minus u by u into epsilon, and therefore, this whole thing, so these two will cancel off and you will get u naught minus u by u into r naught. This is RB1, correct? Now, let us look at the other one. Let us say, let us go here and look at this angle now, which is RB2 plus delta, correct? Because from here to here is RB2 plus delta. So, what is that now? Where do I write now? Let me write here itself, okay? RB2 plus delta. So, that is again of course u naught minus u divided by u naught minus u is equal to, now what is this other angle that we should be looking at? This one, right? Correct. So, that will be r naught plus epsilon by u. Epsilon by u. So, RB2 is equal to u naught minus u by u into r naught plus epsilon minus delta, and therefore, clearly this is again u naught minus u by u into epsilon is delta, and that cancels with minus delta, that leaves you with u naught minus u by u times r naught. But that is the same as what you got here, therefore, this is also equal to RB1. Therefore, we can say RB1 is equal to RB2 is equal to, let us say, the blur radius RB. See, I mean, had I taken this point here, it would have been very obvious that, it will be a circle. But then, what I wanted to show you was irrespective of, so what this actually means is that if you had a plane like this and then from wherever you are imaging, the point could be anywhere on the plane, does not have to be on the optical axis and all, it will still map into a circle, right, a blur circle. That is why we call this a confusion, a circle of confusion. Okay, now the blur circle radius, okay, this is the radius of this blur circle. So, you can think of this as some kind of a blur circle, right, that is getting formed, and this is the radius of the blur circle. If you had if this thing was all in focus, then of course this radius would have been 0, because then you would have had simply the point coming into focus, right?